As we continue to talk about carboxylic acids and their reactions, I want to revisit the concept of a neutralization reaction. In a neutralization, an acid reacts with a base to form a salt and water. And, after all, a carboxylic acid is an acid. So let's look at the reaction between a carboxylic acid and a base. For this reaction, I'm going to use a 4-carbon carboxylic acid, butanoic acid. So we have 1, 2, 3, 4 carbons. We're going to react this with a base, and that base will be sodium hydroxide. And so this will be our base. And when the reaction takes place, this is a strong base, so it will be completely dissociated. There will be hydroxide ions in the water and sodium ions in the water. The hydroxide ions will attract the H from the carboxylic acid off of this hydroxyl group, and these will get together to form our water. What we have left over is the remnants of the carboxylic acid. So I'm going to draw that. And since we've lost this H, the O will still be there. However, it's going to have a negative charge. So this is the anion of the salt that we're going to form. The cation comes from the sodium. And so we have what we would call a sodium and a carboxylate. So our carboxylic acid becomes a carboxylate salt, and we call this sodium butanoate. And this is a carboxylate salt. A carboxylate salt then, or a carboxylate ion, combines with a cation, the sodium, to balance it out. And we write it as a minus and as a plus because they're not actually going to form a solid in the water. We wouldn't get a solid sodium butanoate until we evaporate all the water. So the products of this neutralization are a carboxylate salt and water.